Welcome to the part 4 of the series Acid, Bases and Salt, where we have been on quite a journey, starting from part 1, what are acids, part 2, what are bases, and part 3, what are salts. Well, if you haven't watched any of this video that I just mentioned, I suggest that you go back and watch them, and if you have any questions, you can discuss them in the comment section. Well, today we're talking about pH. But before I say anything else, I'd just like to tell you that there's an interesting clip in this video that your curious minds wouldn't want to miss, so I suggest that you watch this video from the beginning to the end so that you do not miss this interesting clip. Okay, back to pH. First of all, we need to know how to write pH. pH is not written like that, neither is it written like that, nor is it written like that. pH is actually written like this. Now, pH is defined as the measure of the hydrogen ions present in a solution. It is also defined as the measure of the acidity or alkalinity of a solution. Well, pH is the Latin abbreviation for potenz hydrogenii. That's not speaking Latin. Well, when this abbreviation is translated into English, it means power of hydrogen or potential of hydrogen. And this pH was brought about by the father of pH, Sorensen. The name is so funny. He defined pH as, please note the definition, he defined it as the negative logarithm of the concentration of hydrogen ions to base 10. His definition was actually a formula which can be used for calculations, but I'm not doing any calculation in this video. But if you want me to do calculations, you can place a request in the comment section. Now, pH is very important in the life of living organisms. For us humans who have delicate organs, once our pH changes or fluctuates, it could be fatal. For example, our blood, the pH is around 7.4. If that pH should drop even less than 7.25 or increase more than 7.55, it could be fatal. Even in our stomach, the pH is around 1.5 to 2.5 because of the acid that is present. If this pH should increase more than that, you may not be able to digest food. And even plants need a stable pH around 7 to 8. But the soil that they are rooted in can change pH from 4 to 9. As a result, farmers actually climb to their soil not to reduce their acidity. So, maintaining the pH of the soil is vital to the survival of plants. Before I continue, I just want to remind those who haven't subscribed to subscribe. And if you find this video interesting and useful to you, you can please hit the like button and also do so for the rest of my videos. Okay, let's continue talking about pH. Now, other than the calculations that I mentioned earlier in this video, the pH of a solution can be determined by indicators. Now, these indicators are organic dyes which could be weak acid or weak bases that change their color according to the pH or the hydrogen ions in the solution. Now, in the part 1 and part 2 of this series, we already discussed how litmus changes in an acidic or an alkaline medium. Now this makes litmus paper an acid-base indicator. Other acid-base indicators could include universal indicator, methyl orange, methyl red, and phenolphthalein. But these are the common ones I just listed. And if you don't have an indicator at home or you're unable to get an indicator, hopefully sometime in the future I'm going to upload a video that teaches you how to make your own homemade acid-base indicator. Before we continue, watch this clip. Have you ever wondered why an acid-base indicator like the universal indicator I used in this video changes color respectively to the pH of solutions? Well, subscribe and stay tuned to my channel to find out.